Hi there, this is 10L question 5 and question 6. This goes into trigonometry, and there's little bits that you need to know here. In particular, the formula for the area of a segment, which I mentioned at the end of the last video. So, okay, let's just look at this question 5. A and B are 2 points on a circle, just as you see below. Let the angle AOB be theta and be increasing at a rate of, right, so we've got the theta dt rate, which with respect to time, and we know that that's equal to 0.2. Now at the bottom it says find the rate at which the area of the minor segment formed, so in other words, this thing here, okay, you remember the segment is an area one side or another side of a chord. Minor segment is the smaller side, and the major segment would be this side over here. Okay, and so the rate at which the area is increasing, so we need dA dt is what we're looking for, and we'll do that by splitting dA and dt up. We already know that we have d theta dt, so we'll put d theta in there, and we need dA d theta. Okay, well, we need then a formula for the area of the segment in terms of theta. Now, this is essentially the area of the sector. Take away the area of the triangle. Now, what you don't know, because it was previously done in a previous chapter, is that the area of a sector is in fact really easy if you use radians. I'm not going to explain that one now, but it's this formula here. It's half r squared theta. In fact, it's the same as doing pi r squared and then timesing that by theta over 360 degrees. Apart from it works out nicer in radians. Okay, so you need to go with this essentially. This is the area of the sector. And then we're going to take away the area of the triangle, and you know the area of the triangle, it's a half a times b times sine of the angle in the center. That's the alternative version of the area of a triangle formula which we have. So this is take away a half AB, which is going to be r squared, and then sine of the angle between them. Okay, so there's the area of a segment. That's what we need to differentiate. So we need to find dA d theta. So dA d theta, sorry, dA d theta, and the question is fairly easy from there onwards. dA d theta, you're saying that this is constant. Okay, r is not changing here. The variable, the thing which is changing, is theta. So this is just like differentiating 4x, it becomes 4. Okay, so in this case, we're just going to be left with the constant in front of theta. And sine of theta goes to cosine of theta. So we've got this constant in front of it as well. So let's keep that constant there. So a half r squared theta cosine of theta. So there's dA d theta. And now this question is essentially done. So this can be substituted in here. 0.2 can be substituted in here. And we can put theta into this formula as well. And then we can get the answer. Okay, now let's just have a look where I am on the page. Okay, question 6. Question 6. Now, the first bit of this working out, I think you've done before earlier in the chapter, but it's a good bit of recap. This is a very common question. And let's just do this. So tan we spoke about earlier, and I put these formulas up on our stream as well. So tan is equal to sine of x over cosine of x. Some of you might know that from before. We will go back to that again. And that's an identity. That's true for every value of x. Okay, so in this case, we have our function is equal to a u divided by v quotient. So u is equal to sine of x. V is equal to cosine of x. U dash is equal to cos x. V dash is equal to minus sine x. And then we can substitute everything into this formula here. So that's going to give us our derivative there. And you will see that it will simplify to this. On the top, I think you get minus sine squared x, and then minus cos squared x, and that's all divided by sine v squared, yes, sine squared. Hang on a second. Oh, messed that one up. I'm sorry, you can probably see my mistake. Okay, I was going to say that's equal to sine squared x, but that's not, is it? Because in fact we've got cos x there. I'm going to snip this one.